about 10 techniques, but I'm not going to go through the very basic stuff like how to use where clauses and join clauses properly with indexes to make sure you have good search arguments. These are uncommon techniques that aren't well known, but provide really tremendous performance gains in your code, and also help you avoid some of the most common mistakes that folks make because they just don't know SQL Server's behavior that well. So that's kind of the emphasis here. I do have a slide here to tell you about SentryOne and the products that we make. This is going to be folded in, as I mentioned, into SolarWinds. And the cool news here for me is that what SolarWinds has decided to do is that SQL Sentry, if you will, the company that they've acquired, is going to be their database center of excellence. So they already had 2 products for databases, and those are going to be merged into our workflows and our team. And so it's not quite a separate business unit. It's called a center of excellence. So the way we market and sell and the way we support our products, which are all, as you can see in the lower right-hand corner here, we're actually not just in the top 1% of performance monitoring products, we're in the top 1% of the entire software industry in terms of all of the customer satisfaction kinds of metrics. So time to resolution, time to pick up a phone, time to talk to a support engineer, all of those things, top 1%. We have a 100% customer satisfaction rating on our customer support. And for me, as a former DBA, that's exactly what I want to hear from the company that I'm buying my tools from. Not only that, our tools are the best in the business. They're amazing. They're the BMWs of, as BMWs are to autos, we are of the SQL Server tooling world, but we're no more expensive. So compared to competitors out there. So I hope if you have a need for tools, you will give us a look. Our tool list actually is quite large here on this slide, but it's going to shrink quite a bit. All of these things on the right-hand side that were separate monitoring products for like analysis services, and maybe if you had one of the big data warehousing products like APS or something like that, those are, you're going to get all of that in one license going forward. Then we're also going to have the products that are part of the portfolio for SolarWinds, which includes DPA, database performance analysis, which is a very popular product in the market. Another kind of niche product called DPM, database performance monitoring, which is more like what a site reliability engineer running a big website would want. And another one of our products is super popular, which I'll show during this presentation. It's completely free. We don't even ask for an email address. It's called Plan Explorer. And since we're talking about query tuning, I'm going to show this to you because it makes query tuning much, much easier. And it shows a lot of things that you cannot see when you use Management Studio to do your query tuning. Also, we have a lot of great resources you can take advantage of. Again, these URLs will always work. They'll always forward to whatever their new name might have under the SolarWinds umbrella. So I've done many, many webinars over the years. So check out SentryOne.com/webinar library. If you like this one, there's a ton more that offer even more kind of query tuning information, DBA best practices, organizational best practices, and stuff like that. And then SQLperformance.com. If you haven't added this to your blog roll, but you read a lot and write a lot of SQL code, this is one you want to add because it has lots and lots of really deep, hard-hitting articles on here's a couple ways to write some SQL code, which way is going to perform better. And so some of the lessons learned in this presentation have come from SQLperformance.com. And in case you haven't heard of me, I started my career in the 80s doing Oracle work. 6 years I was an Oracle person for NASA and the Department of Defense. And We put the team I was on, we put the water recycling system into the space station, the ISS, and made 96% of the water that goes through a human body redrinkable on a daily basis. The database stuff was great, but the really, really cool part about that project was the taste test. That was the most fun. So when we have time to chat, I'll tell you those stories. From there, I wrote my first book in Oracle in the early 90s, and I went on to manage some very large estates, one of the largest SQL Server estates in the world during the 90s. And it was during that time that I was tapped to become one of the original 9 founding members of the Professional Association for SQL Server. And I was a president for a couple terms in the early 2000s. And now, PASS has gone through some transformations and is owned in a public foundation by Redgate now. Absolutely deserves your time and attention. You guys are a chapter of PASS, so you definitely want to take a look at that as well. And then I've written many books. We're going to give away a couple ebooks of SQL in a nutshell at the end. It's a $45, $50 book, and it's one of the best sellers in the SQL world. And it was actually a bestseller in the 2000s, believe it or not. It peaked at number 23 on Amazon at that time. So it's a very popular book, and I hope you'll enjoy it. So what we're going to talk about today is I'm going to talk about mindfulness in coding and how to kind of set up your environment for development so that you're doing it right the first time, and exercising control over the caches that you've set up your SQL Server and your management studio, perhaps, so that it is tracking the right metrics. I'll tell you a little bit about execution plans and an interesting way to mimic execution plans, and I'll explain that in a moment. We'll talk about red flags in your code, and then we're going to talk about workloads a little bit and some important things about indexes, particularly around functions and indexes. We'll talk about implicit conversions, and all the while we're going to be switching back and forth between demo and slides to go over quite a bit of this information. If you have never coded SQL before and tried to do performance tuning on SQL statements in SQL Server, this is probably not the right webinar, not the right situation for you. If, on the other hand, you've done a lot of programming and you want to get better at it and you want to write more impactful SQL, then this will be a good webinar for you. All right. So let's start with some introductory concepts. We know that SQL Server has this thing, and all relational databases for that matter, Oracle, MySQL, PostgreSQL, any of those that you might want to use, DB2, Sybase, they all have query optimizers, and they all have learned over time that the best way for a query optimizer to process a query is through something called cost-based optimization. Imagine, in a video game where you have your little character that moves around. Imagine if it didn't have pathing algorithms. So it might go up into a corner and there's a rock there and your little character just keeps getting stuck and doesn't walk around the rock. Well, that's the way databases used to be until the early 90s. They use something called a rules-based optimizer. So let's go through the math a little bit on this, right? The goal of the SQL Server Query Optimizer is not to give you the best execution plan. Its goal is to give you a good enough execution plan. And so let me illustrate that mathematically, why that is so important, okay? Let's assume that we have to write a pretty big query. It's going to select some columns, as I have there on the slide, and it's a 4-table join, okay? So we've got 4 tables, and each of those tables has a clustered index and 1, 2, 3 non-clustered indexes, okay? And then on top of that, each index and each join might be joined together through one of 3 different physical implementations of a join algorithm. It might use a nested loop join, a merge join or a hash join. Okay, so mathematically, how many possible execution plans are we looking at in this situation? Well, the first thing is the physical access methods. How will SQL Server look up this data across all of these different tables? Well, as you can see here, for a single table, but we have 4. For a single table, we have 72 different ways to look up this data. We might do an unordered clustered index scan. We might do an unordered non-clustered index scan because the non-clustered index is a covering index. We might do a non-clustered seek. We might, all these different things, 72 for each of the different tables. Then on top of that, SQL Server will do a behavior called associative transformations on, and also something called commutative transformations on the join order. So it says, okay, I've got to have these 4 tables that I'm joining together, but there's a lot of resources that this query is going to use, and those resources are expensive. So what I want to do is order the joins in such a way that I eliminate or filter out, using the where clause and the join clause, filter out as many rows as early in the process as I can. So again, assuming these four tables together joined with our query would produce 1,000 records in the result set. But each of those tables has 100,000 records in them. So what SQL Server is trying to do is it's trying to figure out if I join, let's say, table C to table D first, and I eliminate 999,045 records on one, and then all but 46 records on the other, that will eliminate half of the records that we need to retrieve right away in the very first join. And so I can give you a smaller memory grant. And so I can do things like that to speed up the process. So SQL Server will reorder all of those different joins to figure out which will be most effective. That's 24 mathematical new probabilities. And then on top of that, we have those physical join orders. We have intermediate result sets that SQL Server might use. So for example, if we do a hash join, SQL Server is always going to spill that intermediate hash table into TempDB. And so that's going to produce new alternatives. For a 4-table join, we're looking at about 26,000 different query plans that SQL Server would use to produce a result set. And because of that, when I start to think about it, it's like, well, sometimes I'm really pleased that SQL Server has given me a result set at all because of all the different things it has to consider to do to produce that result set. Now, again, it's not trying to give us the best strategy because so many of these different execution plans, A and B, are almost the same in terms of the total amount of time it takes to give you either A or B. So the amount of time it takes to evaluate all 26,000 plans is not part of what SQL Server wants to do. What it wants to do is give you either A or B because they're both good enough, right? They're both good enough to give you a result set quickly in a way that you're satisfied with it. So that's what SQL Server is seeking to do. One of the things that this session is seeking to do is I'm trying to teach you some of the most egregious things that cause a lot of problems in our execution plans and makes the optimizer work harder. So by learning some of the lessons that we're going to cover today, hopefully you won't have to work so hard. Okay. So the first thing that you need to do, that you want to start with, is a test harness. Now, back in the old days, this was really important because SQL Server was not good at controlling most aspects of its internal behavior. And I'll give you an example. Back when I first started working with relational databases, one of the things I would do, and in particular with SQL Server, I was given this job to rewrite a poorly performing stored procedure. And it took probably 30 minutes to run. And so the way I decided to test this, it was pretty new at the time. So what I did was I ran the query as it existed, or the stored procedure. And back in those days, again, not much instrumentation. We didn't have X events or perfmon counters or things like that. I just had a stopwatch, and I ran it to see how long it would take. And then as I was looking through the code, I saw one alternative that I wanted to try right off the bat. Back in these old days, SQL Server 4.21a, SQL Server did not know how to rewrite a correlated subquery as a join behind the scenes. It does that now, but back then it didn't. So what I had was several correlated subqueries, and I decided to rewrite them as joins. And I ran it again. It was incredibly fast, took just a few moments. And so one of the more senior people on the team was walking by my cube as I was celebrating, hey, I'm so good at T-SQL. And they're like, well, what did you do about the caches, Kevin? I was like, what caches are,
what caches do you speak of?
I didn't realize what had happened was when I ran that first query, it used all the same data that I was going to need in the second query. And so what SQL Server does, its behavior is to cache, to store frequently used data in memory in a way that it can be quickly retrieved. And so the first time I ran it, there was a cold cache. There was nothing in there in the SQL Server cache that would answer the query that I was asking of it. However, the second time I ran it, it saw that there was new code, so it needed to compile a new execution plan, which it did, but all the data it needed was already up in the cache. And so the reason the query was so much faster wasn't because I was some fantastic query tuner, it was because all the data it needed was already resident in memory. So you have to prepare for that. And so I'll show you, here are the statements that you can use to clear your cache. Back then, by the way, when I was learning this lesson, it was a hard lesson. We didn't even have these statements. The only way you could clear a cache back then was to restart SQL Server. And there was no, no way to get just the plan cache or just the data cache. Boy, it was a mess. So I learned a few things about keeping up with the right metrics. So let me show you that in a little query here. All right, so the first thing that I like to do is I like to just set the start time of the code that I'm going to test and put it into a variable. And that way, if I'm testing multiple SQL statements, I can test them all in a batch and see what the total elapsed time is. Because otherwise, SQL Server will try to just tell you statement by statement how much time is passing. Another thing is that in SQL Server, any pages that are in the cache that have been changed, those are called dirty pages, and they remain dirty until a checkpoint runs. And so I actually will manually issue my own checkpoint as I'm running code so that it won't randomly decide, SQL Server won't randomly decide to invoke the checkpoint behind the scenes and then kind of make a query that would run fast run a lot slower because it's writing all these 8K data pages to the database, right? So let's clear all those dirty buffers. And now we only have clean buffers. And then I can, as needed, I could say, you know what, let's drop clean buffers. That will clear the data cache. Or I could say free proc cache, which would force all of the execution plans out of the plan cache side. So I can clear things up that way. Then I also like to use these statements here, set statistics IO on and set statistics time on. So this gives us some very useful sorts of information. You could also go over here to query and then look at query options. And then if you look at advanced, you'll see that you could set statistics time and set statistics IO here on this page. But I just use the
I was going to say we have a question from Matt saying the lazy writer process will also flush dirty pages to disk. Is that correct?
No, that's not correct. The lazy writer primarily, that's a great question, by the way. Lazy writer primarily handles page eviction. So if you have a plan cache that's I'm sorry, if you have a plan in the cache that's very old and hasn't been used in a long time, it will evict that plan from the plan cache. If you have a data page that's very old, but it may not be dirty, okay, it can evict pages from the cache. So yes, you're correct in that the lazy writer kicks pages out, but it doesn't kick pages out based on whether they're clean or dirty. It kicks them out based on how long they've been in the cache and have they been reused recently. If they haven't been used in a long time, it actually has a countdown timer and will kick those out of the cache if they're just really old and no one's asked for them for a long time. So great question. So let me go ahead and execute these and show you what the results look like. Now I'm going to go ahead and execute a query. And the other thing you really need to turn on, of course, when you're tuning queries is the actual execution plans. Okay, so I'm going to click that little button up here, execute some T-SQL code. And so you'll see that it's finished. And a couple things to note. First is, of course, the execution plan will be here under the execution plan tab. Let me make that a little bit bigger. And you can see how it kind of, scrolls way down the page, and they're all the way over here to the lower right corner. And to find out what is the most expensive step in this is kind of hard. You have to look at every single operator going upward and to the left as you move through this result set and this execution plan. The set statistics IO and time on, that shows up here in the messages tab. And so this is the stuff related to set statistics time on. And so we can see that it had a CPU time of 15 milliseconds and an elapsed time of 17 milliseconds. And there are times when you'll see the CPU time higher than the elapsed time. And that's because of parallelism. So SQL Server actually gave time to 4 CPUs, and all 4 of them took 15 milliseconds each. And so the elapsed time might still be 17 milliseconds, but the CPU time would be 60 seconds, right? So that's set statistics IO, I'm sorry, time on. Set statistics IO on shows you all of this stuff here. So we can see that this looked like a really simple query. Where is that query? Here it is. But it turns out this is actually a view. And so we can see behind the scenes, there is quite a lot of activity going on here. Work file and work table, those are kind of yellow flags. What this tells us is that SQL Server had to create an intermediate result set in TempDB. However, the scan and logical reads and all that is so low that it's not a problem. If these numbers were big, I might be worried, but they're not. The next thing it tells us is the different regular tables, user tables that are used. And this could be a full table scan, or it could be a range scan, which we know to be the case because we have a between. So that means SQL Server will scan a range of values. And then these numbers here are where we also look for red flags. So if you have a high scan count, that's a red flag. If you have really high physical or logical reads, this number means 8K data pages. A logical read means those 8K data pages came from memory. That is, the data that I needed was already in the cache. The physical reads means that it had to go to your IO subsystem, put it into the cache, and then answer your question. So in this case, we have a situation where we didn't have to do any physical reads because that data was already in the cache, okay? Now, if I were to clean these buffers out and do this all over again, we'll probably see some changes here. So now when we look through these, we see that we do have some physical reads on each of these. And this read ahead means it's going ahead and grabbing additional 8K data pages because it feels like there's a really good chance I'm going to need more than just this 1 or 2 or 3 physical pages that we used in this query. So it's actually accumulating a fairly good amount of I/O in this particular situation, but it's not so much that I would really be concerned and feel like I really needed to tune things. Now, let me show you Plan Explorer also. The reason I want to show you this is Plan Explorer really kind of pops out at you when you see the how it presents an execution plan. So I'll just paste that SQL statement and I'll say, give me the actual execution plan. And so do you remember before what the query plan looked like over here? It's kind of hard to tell, you know, what's the most expensive operator in this execution plan? Well, you know, I guess I could look through each of these different steps to figure that out. If you look in Plan Explorer, it just tells you right away what's the most expensive, what are the you know, next most expensive and the next most expensive. In this case, we even have a clustered index scan, which means it's going to read every row in that table. So it's going to be quite expensive in this circumstance to read that. Also, it will tell us a whole lot more information. For example, there's a tab down here called Table IO. You can see that down here at the very bottom. And that does for us all of the what is it, set statistics IO on. In this case, there's no IO because we've already cached all of that. So there's no physical IO for us to worry about. So again, we can see all of the things that are happening. We can do little adjustments to it to make it more visible. We can see that there's a little exclamation point. So whenever there's some kind of missing statistics, missing index, maybe a spool or a spill warning of different kinds. So there's lots of, I've only shown you the tip of the iceberg, but just for tuning queries, that's your first step there. Okay. Now, this will stay on until you turn them off. So it'll drive you crazy if you leave it on and running, but I'll go ahead and turn it off there. Okay. Were there some additional questions?
Not at this point. There was a question earlier from Sean in regards to some of the monitoring products that SolarWinds happened, but if it's okay, Sean, we'll just hold off on maybe answering that until the end.
We'll hold that till the end. Yep. Okay. So the idea is you want to make sure that you have the exact same caching, the exact same environment, because if you don't, when you compare two versions of the same query, you're going to compare apples to oranges, not apples to apples. So you got to make sure that you're what you're testing against on your machine is consistent from one run to the next. Now, a lot of us know that when we are executing code, that SQL Server builds execution plans from 3 distinct kind of domains. The first is the metadata. This is the data about our data, where to find the data, on what 8K data page it might live, how quickly can I get to it, if I execute a query against this index, how many rows are likely to be returned. That's called the cardinality estimate. So the metadata is one of the biggest areas that we need to get a good, strong performing SQL statement. Okay. Now the indexes are provide us with something called statistics. Okay. So if you create an index, it will build statistics on the column or columns you have asked for in the create index statement. SQL Server will also collect those itself. So if it sees that, say, there's a date column in a particular table, and people keep saying where that date is greater than a certain, SQL Server will say, hey, you know what? People are using this all the time as if it was indexed, and it's not. So I'm going to go ahead and create statistics on that for you, just like it was. And then there's one level even deeper than the statistics. It's called the histogram. And the histogram is information about the distribution of records on the various spots along the way for the index. So it might, the histogram might say that on this particular set of records, it's much heavier on the right side, at the more recent side of this index, and far lighter on the left side. So that histogram can tell us that we need a bigger memory grant the more recent the data is that we're asking for. So that's one area. Another area is in the set options. And this is not one I'm going to demo, but let's say you changed some of the important settings, like set ANSI nulls off. And you put that in an ODBC connection string. But everybody else doesn't have that in their ODB connection string. That means you will get a different execution plan than everyone else. Same thing if your workstation had a different collation than the Windows server where SQL Server was running. So let's say yours was Swedish for some reason. It would say, okay, that's a whole different collation. I will need to give you your own special execution plans compared to everyone else. And then finally, there's actually the physical aspects of the server itself. There's CPU for parallelism. There's memory for memory grants, stuff of that nature. So one of the cool things that a lot of people struggle with as developers is that the production machine is like this massive beast. It's got 512 gigabytes of RAM. It's got half a terabyte of RAM. It's got 128 CPUs available, cores available to it. And here I am on my little laptop that has 8 gigabytes of RAM, and it has 4 cores on it. I've got a copy of this database here, and yet it gives me execution plans back for my queries that are nothing like in production. So I'm constantly saying, okay, I finished this particular piece of work. Now I'm going to put it in production, and then it works terribly. So here's a unknown, uncommon technique. I'm going to show you how you can mimic that production database, even though it's still the same 300 megabyte version you've been using all along, but it will give you exactly the same execution plans as production. Okay, so let me show you how to do that. The first thing you have to do is you have to build your clone database. Okay, and the clone database is not simply, taking the production database and, restoring it to your laptop or something. And particularly if it's huge, that won't work. So what you have to do is you have to build a clone. And one of the things too is that there is a statement, DBCC clone database. I'm not going to teach you the way that way of doing it because at present, if I remember correctly, it's only going to make a clone database on the same server. And what we actually want to do is to make a clone database on our laptop rather than in production. So what you do is you find the database that you want to clone. So here it is in production. You right click on it, and we're going to script out the database. However, there's a selection item for scripting the database. Don't use that one. Microsoft lies. Instead, use tasks, and then you'll see generate scripts. Okay, click that. There's a little wizard that pops up, and let's say in this case I'm going to script the entire database. Okay, the secret ingredient is here under the advanced button. When you click the advanced button, you may have used this method to generate a SQL Server database before. However, you may not have known about some of these features. Right above the first bold-faced entry, there is an entry here that says script statistics. And the default is don't script statistics. So wouldn't it be great if we could get all those index statistics, all that metadata? Well, in fact, not only are we going to script statistics, we are going to actually go a step further and get the statistics and the histogram. Okay. And then We'll save it as a script file, and you can give the location and all that. It only takes a few moments to run, but I'm going to go ahead and skip this step. Here's what you'll need to change once you have your output file. The first is, of course, you probably want a much smaller version than what's in production. So on this first line where it creates the database files, you'll want to change the file size, whatever that might be. And then the next thing is you'll see that it says alter database, set auto create statistics on, and it'll say set auto update statistics on. You need to turn that off. The reason is you're pulling statistics and histograms from production, which makes it think, makes your local laptop think when you create this database that it's not 300 megabytes. It will think that it's that half a terabyte size database or 2 terabyte size database you have in production. And if you don't turn these off, SQL Server at some point will decide to update those statistics for you and set them back down to what really exists in the database. So you don't want that. So let's jump forward. So you probably have seen these kind of scripts where it creates the database, sets all of the different parameters, then it starts to create the different users, it creates the objects, it creates all of the tables and so forth. Something you may not have seen before are these statements here. Update statistics, and then it says the table, well, rather the database, the schema, here's the table, and then here is alternate key such and such. So that's the actual index that it's updating. And now it says with stats stream. And this is the actual hexadecimal representation of the index with its histogram, all of its statistics in its histogram. So even though this table might actually be empty, because you have changed the metadata, SQL Server thinks that this particular table, sales territory, has 400 records in it, even though it's completely empty. So that is 2/3 of the equation for producing execution plans on your laptop that will be exactly like what they are going to be in production. Okay. You'll also notice these little objects here where it says _WA and then sys. That is a auto-created statistic. So it's, remember that option that says set auto-create statistics on. And so this is one where it said, oh, you know, the sales territory history territory ID is being queried all the time. So I'm going to start collecting statistics on it. Okay. Now you'll need to get some data into your database, but I do have a little script here that shows how to do that using DBCC, and it will iterate through all your tables and pump out 10,000 records for each of them. But you can use whatever technique you want. You could use, you know, import export wizard or SSIS or ADF, whatever. So remember in our Venn diagram, we had the metadata. We're going to ignore the set options for now. The other big area is physical hardware on that server. And again, we got a situation where I've got a much smaller SQL server on my laptop than what's in production. So wouldn't it be great if we could tell SQL Server, just pretend like I had all that RAM or all those CPUs? Well, we can do that. What we can do is we can use a special statement called DBCC optimizer what if, and we can say for SQL Server, hey, I want you to pretend like I have 64 CPUs. And I want you to pretend, SQL Server, that I have a terabyte of RAM, okay? So when I execute this SQL statement now, it thinks that I have all of the it looks at the metadata and it says, oh, okay, it looks like this is a terabyte sized database. Wow. You know, and all these tables have hundreds of thousands, millions, billions of records. And then we've told it these DBCC options, and they stay in play as long as this session is open or until I turn them off. So when I execute a SQL statement, it will produce an execution plan that is the same as what I would get on that production server instead of the same as what I'd get on my little workstation. Okay. And then what you do now, note that that doesn't mean the performance will be the same. You know, if we're looking at our stopwatch testing the time, it could be way different because we don't have the same IO subsystem. We don't actually have that amount of RAM. You know, so it's going to be different. But what this is really useful for is it will help us identify poorly performing query plan operators. So for example, here it says we have a merge join, but merge joins only work really well in certain situations. So it might be that we could tell by looking at this, maybe I don't want it to use a merge join. We can also see that it's parallelizing everywhere. You know, of course it would, because it's got 64 CPUs, right? It's got a very costly sort operation here, where it's doing quite a lot of spilling over to tempdb. Okay, now let's go ahead and turn that off. I'll do a reset all here. And if we execute the same stored procedure or the same SQL code again, let's see if we get the same execution plan. Probably will, but you never know. Okay, so yes, I didn't change the amount of parallelism. It still has parallelism enabled. However, let's take this the other direction. And what happens frequently when we buy really, really big servers is that we virtualize it and put, you know, 24 servers on there with 2 CPUs each, right? And 256 megabytes of RAM or something like that. So we can actually go the other way too. We could say, make this a really small SQL server and tell me how this will perform. So now if I come back up here and execute this exact same query, what we're going to see is a very different execution plan. Now I do have a slide, by the way, that points, if you don't know much about query tuning and reading execution plans, it will point out, that slide will point out things you want to look for. And so notice here, yes, there's no parallelism happening at all. Also, the sort that happened after the join, which was a merge join before, now happens way earlier in the code, as right after it does its clustered index scan. Okay, so very different execution plan, very different cost. All right, so this is a way that we can get SQL Server to produce execution plans that are the same, even though the version I have on my laptop is crazy different in terms of the hardware and, you know, the disk subsystem and all those kind of things compared to what's in memory. Does that make sense? Any questions? Okay, so.
Yeah, no questions at this point.
All right, great, thank you. So red flags in those operators, anything that says lookup, like if it says key lookup or row ID, RID lookup, that's usually a red or yellow flag. Anytime you see really big scans, so it could be a clustered index scan. I used to not worry about clustered index scans because like, hey, it's an index. Well, it turns out, you remember, clustered index is every record in the table. So a clustered index scan may not be reading every column, but it's definitely reading every row. And if you have 2 billion records in that table, then it could potentially be a very big result set. You'll see those spools and spills often appearing as a sort operator. So this means an intermediate table has to be created in tempdb to give you your result sets. For example, anytime you have a group by, you're almost guaranteed to have a spool or a spill happen. And if you have a group by with a having clause, you might even have 2 or more. So, you know, interesting things to look out for because that can really slow you down. Certain merge joins and hash joins also do a lot of work in tempdb. So they're expensive operations. And then we have other things that we want to keep an eye out for that are not simply in the execution plan operators. They appear in other places. For example, sometimes it's really useful to do the estimated execution plan and then pull the actual execution plan. And if you see any differences at all between those two numbers of the number of records it thinks it will retrieve, you know that your indexes are out of date. Okay.
Carol is asking, what's the difference between group by versus distinct? Might need a little more information, Carol. Go ahead.
There's a lot of differences. So let's hold that one for the end, and we can go through that in a little bit more detail. One of the interesting things too, though, that I do want to show you is that in Management Studio, you have to look at all of these things and manually look at them and eyeball them to figure out where a particular problem is. So if we were back here in Management Studio, let me see if I can find here's a very simple query. It's going to have a very simple execution plan. So it will point out for you, the things that I was already showing. Okay, here's my two plan operators. The first is it does an index seek on the sales order header person ID column right here where it says person ID equals 283. Seeks are very fast as opposed to scans, which can be not necessarily slow, but they can be very slow. And then it does its select of the data that we want. However, there are other cases where it can be a lot more elaborate in your execution plan. And so you would have to look through every single one of those to find if any of them are expensive. However, if you're in, well, let's do this one. It's going to have two steps. Okay, so we've got a main query, and then we're going to pull some of our data out based on a subquery. So in this case, this where clause can be said to be a search argument or a SARG. And so we see now that our execution plan has two index seeks. It uses a nested loop operator to join those two result sets together, and then it gives us that final select statement. Okay. Now, one of the really interesting things about relational databases is they work really well on sets of data. So like this set of data here, all of the business entity IDs where the person's last name and first name equals David Campbell, right? So we have two actually. And then we have this other one, this other result set that pulls all of the sales order IDs where the salesperson is David Campbell. So we see quite a lot of those. What happens when we ask SQL Server to find not a set? Do you think it's going to be easy for SQL Server to figure that out? So basically, if you're thinking, yeah, it's going to be easy, it knows what to do. It should have basically the inverse of the execution plan we just saw. But in fact, check this out. That is way more complex of an execution plan. And all we're doing is saying where salesperson ID isn't equal to 283. So what SQL Server and all relational databases actually have to do behind the scenes is they have to remember what set you don't want to find, and then compare every other set that exists to it to rule it in or out, to rule that search argument is true or false. And so it means a much bigger, much more complex execution plan when you look for not a value, okay? But here's the cool thing. You can get the same results by simply changing to a set-based approach. So what I mean by that is every value, find me all the sales order IDs where the salesperson IDs are less than 283 or they are greater than 283. So what am I ruling out? I'm saying where they're not equal to 283. So let's look at that execution plan. Now I'm looking for two sets instead of every set except 283. And look at that execution plan. Much simpler, much simpler, right? Very easy to deal with. And it happens in subqueries too. So this one, which we just saw a moment ago, has two index seeks, right? But if we say where the business entity ID is not in David Campbell, we look here again, boom, got a big complex execution plan, and we have an excessive memory grant warning too. Wow. And the way we could recode this so that it finds everything except sets with David Campbell in it would be to use a left outer join. That's how we could do it. Okay. So, in showing that to you, let's take this now over to Plan Explorer. And you can, again, if you don't know a lot about SQL statements and reading execution plans, hopefully this will make a little more sense when I show you here. Let's get that actual execution plan. And when we look at it in the query optimizer here, you can see, based on color coding, wow, there is a lazy spool spilling over to TempDB. And that's what's really expensive in this query. Also, something that happens up at the top, up here, to best fit. Notice it already knows that the estimated row count and the actual row count are going to be very different. So it already knows that I have a problem with having stale index statistics on that particular column. So there's a lot of cool features built in. All right. All right. So let's move along here. Got a lot of folks who don't really understand that there are issues with our indexes in general. I've actually just done a series of indexing webinars. If you're interested in that URL, you can see, to watch those webinars, you can see them on MS SQL Tips. And the next one that I'm doing will be next Tuesday, I believe, on the 27th. So if you're interested in writing better indexes, join me for that session. But one of the things that we see is a lot of developers kind of get it in their head that indexes equal go faster. And so they index everything. And indexes don't actually go faster for everything. They can speed up read operations, which is to say select statements, but they don't speed up in most circumstances, they don't speed up your write operations. So your inserts, your updates, your deletes, your merge statements, probably not going to speed those up. And in a lot of cases, they can even slow them down because of the way writes work in SQL Server. So when we have an index, let's say this is the creation of a clustered index. So at the bottom, we have what we call the leaf pages. That's the data itself. And then SQL Server creates called a B tree or balanced tree index. And it can have multiple levels in between the root page and the leaf pages. And so instead of having to do a scan across all the AK data pages at level 0, SQL Server is able to just read, say, the root page, then the intermediate page, and then the one page itself at the leaf level that it needs to change. Now, imagine if all of these pages are completely full and someone comes along and says, I need to do a DML operation. I need to do an insert to this very first page here, but it's full. SQL Server performs an operation called a page split, which is extremely resource intensive. What happens is SQL Server will take half of those records that exist on that first page and tear them away from, lift them off of the first page, and it will rewrite those onto a new page. The only thing about that is the new page that it writes it on is simply the first AK data page it finds that is completely empty. And so what you get there is an index that normally would be read in some circumstances serially, because we're doing a range scan, or maybe we're scanning the whole thing. But we have just introduced now logical fragmentation. And so to read those values in order on that index. It has to start here and then go to page 27,000, then come back to page 18 and then read, and then, oh, there's another page split happened at some point in time. So you need to be aware that writes can cause this index structure to fragment naturally over time. And so if you are designing a database that is very heavy on writes, particularly if they're singleton writes, then you want to make sure that you lean towards fewer indexes. Whereas if you have a database application that is very heavy on reads, then you could put more indexes on those and see an overall improvement in your workload behavior. Now, another thing that a lot of devs and DBAs that I've worked with over the years don't realize that when you when you put a function call on a column that is indexed, chances are SQL Server will not be able to use that index. So normally, if we were to say, return to me all the dates that are between such and such date and this other date, okay? SQL Server would then be able to say, okay, is it starting on the root page of the index, is it less than or greater than this value? Okay, well, it's on the lower end, so let's go and find all of the stuff that is dated as, let's say, 2001 through 2005. So that takes us to the first page of the intermediate level, and then it says, well, this is in 2003. So that will point us down to the second page of the leaf nodes right here. So I was able to read that in 3 8K data page reads. However, if I put a function call on that statement, then SQL Server would say, okay, you know what? I'm not really sure about those values anymore. So let me see if I can figure this out here. You've got, maybe you just changed it to a date value or something like that. Well, what SQL Server may do is it may say, oh gosh, I better not use that index because I'm not sure anymore what those values are. So just a very simple example, you see this all the time where in a stored procedure, we're not sure if the user of the stored procedure is going to give us a value. And so we haven't set it up to handle nulls. And so we're going to say, where is null salesperson ID? Change that to a 0. So before, remember, when we do this, we get that very clean, very efficient index seek on the non-clustered index. But if we have a where clause on it, where there is a function call on the indexed column, it's a pretty good chance. And sure enough, you see here, SQL Server cannot do a seek anymore. It has to scan the entire thing, okay? So much poorer performing behavior out of SQL Server when you put a function call there. So the way to get around that would be to maybe set a default. So if that a person doesn't give us that salesperson ID, it will default to 0. So then instead of saying where is null salesperson ID comma 0 equals the value, we say where salesperson ID without a where clause, I'm sorry, without a function call equals the parameter. And we know the parameter will never be null. Okay. All right. Now, this is a biggie as well. Something called implicit conversions. Okay. And as it turns out, inside a SQL Server, there are all kinds of data types that you would think are completely 100% compatible, but they aren't. So for example, if you had in your tables a bunch of values that were in varchar right here, but the developers weren't paying a lot of attention. So when they wrote some stored procedures and when they wrote their front end code, they just used varchar. I mean, they both have the word varchar in them, right? and yet they are not directly compatible. So what SQL Server does is it says, hey, you know what? I know what you mean. I know you mean well. So I'm going to implicitly do this conversion for you. The only problem is that it is a massive performance hit. Okay, so here you can see the CPU consumed is bubbling along at about 20%, but then when the implicit conversions start, it goes up to 80% CPU consumption. It takes, batch time goes up by 10 times to complete, right? It goes from 1 minute to 10 minutes. And this applies to several different kinds of data types, not just varchar and char, all of those text types compared to the in text type, but also some of the numeric types, float or decimal or number or money. You'd think that it would work well with integer or any of the int types, but it won't. It will implicitly convert behind the scenes, okay? So I'll show you that in a quick example too. Let's see here. So let's see. Go to good old AdventureWorks here, and I'll create a table called product category, and it's got category ID as an integer. But then there is a different table called product that has category ID as varchar 10. Okay. All right, so it looks like I clearly did not clean up my database from the last time I performed this demo. So now I'm going to insert some values into these tables. All right, got some duplicates, but now check this out. I'm declaring category as an integer. So let's just say there is a stored procedure that has been written, and the person used integer for category ID instead of varchar 10. So when we execute this particular piece of code, what we're going to see is that on one of those columns, we have a scan, but on the other, we have a seek. That's because one is implicitly converting the value. And also notice this exclamation point on the select, and it tells us right there, convert implicit. And it's going to mess up your cardinality estimates, and it's going to mess up the processing behavior, okay? So it will really, really slow down your code. It could be anywhere. It could be in the where clause. It could be in a join clause. It could be in multiple clauses, okay? So it could actually even be in a situation where we don't have any kind of parameters or anything like that as well. So here, when you put quotes around a number, SQL Server sees it as textual rather than numeric data, integer data. So again, we would get an implicit conversion on this just by having that quoted data there. Now, one other thing that I want to show you is a couple scripts in the script library that are helpful scripts. So one is this big script written by my buddy, Jonathan Cahias. And what this does is it actually will look in the plan cache and tell you if you have any SQL code that actually exists in the cache that has a implicit conversion in it, okay? And of course, it won't keep anything in the cache past the last time the cache was flushed, nor will it do anything with regards to if you restarted the server recently. Oh, looks like it didn't find that one. I guess I must have cleared the cache. The other thing too is that there is also a little script in here that will tell you in a given database if there are any columns of the same name that have different data types or different attributes. So it's a little bit noisy. And as we look down here, we can see that, okay, these are all the same data type. Oh, here's one that's, it's the title column. It's in varchar 50, but all the others are in varchar 8. Okay, so that won't cause implicit conversions. But sometimes you might see some that do. You know, if it's varchar here and then the next one is in varchar, okay, that's going to cause some implicit conversion issues. So that'll help you look at existing databases to see if there is any problems with that design of the database. Okay. All right. Now, how many of us use cursors? Probably all of us. Another two little tips that I'm going to show you in at one time in one batch is this statement here. Whoops, let me go back. It's called set no count on. And this actually causes SQL Server to send less traffic back and forth to the client. What it ostensibly does is turns off the little message at the end of a SQL statement, the done in proc message, that says 6 rows affected. You know, if you did an update, it'd tell you how many rows did it change. Well, it wouldn't show that anymore if you set no count on. The thing is, Microsoft doesn't tell you this, but anytime any Transact-SQL statement effectively completes running, it sends a done in proc message. And that slows things down. So if you have a stored procedure that uses cursors and is going back and forth constantly and it iterates through 3 million times, it's going to be 10% slower than one where you have this code as your first executable statement in that SQL batch. So let me show you 2 little tricks to help make your code go faster under these circumstances. The first is how to write cursors that perform better. And the second trick is how to use that set no count on. So the problem with SQL Server with cursors is that when you declare a cursor, let's see here, all default. Okay, so when you declare cursors, the ANSI standard says you have to support both local cursors and global cursors. Now, global cursors were used a lot when relational databases were brand new. And that's because they hadn't invented stored procedures yet. I remember when I actually got to meet the guy who invented stored procedures. It was a big deal for me, right? So, so therefore, you had to have a way to pass data back and forth between different routines in your SQL statements. And that was done through global cursors. Now, nobody uses global cursors anymore. In addition, the ANSI standard says you have to be able to move up through a cursor result set or down through a cursor result set. You also have to be able to like move forward 3 at a time if you specify. So you could say fetch next 3 C into your ID number, and that means you would read every 3rd record instead of every single record. Or you could say fetch next -3, and it would go upward through that result set instead of downward through the result set. And then finally, the ANSI standard says you have to be able to update the records of a trigger when the cursor is sitting on each of these records. And again, most of us only use cursors to read the result set. So for some darn reason, Microsoft made all of the most expensive and overhead intensive options the defaults. So I'm going to show you 4 variations of this theme. So first, I'm going to create a stored procedure here where everything is default. Then I'm going to create a stored procedure that is local, that has the words local fast forward. So what that means is I'm only going to use local, not global cursors. I'm only going to go forward through the record set, result set, 1 record at a time, and I am not going to bother with needing that updatability that the default allows. Okay, so version 2 is just local fast forward cursors, the good version of cursors. Number 3 is just set no count on. And then finally, number 4 is both of those. And once all of those stored procedures are created, we're going to execute all of them 5 times. So that's what go space 5 means. By the way, that go space 5, whatever number you put after the go statement will execute it that number of times, and it only works inside a management studio. So you can't do that like in a stored procedure or something like that. Okay. Now, let's check in the plan cache and see what these queries have accumulated in terms of the resources they have consumed and the amount of time it took to actually process all of this. So what we see here is the max running time of each of the different stored procedures. That's the max running time. So notice that number 2 is really faster than everything is default. Number 4 is neck and neck, but just a tiny bit slower. And then the total elapsed time for all of them. Number 1 is a lot slower, total elapsed time. Number 2 appears to be the fastest here. Just set no count on is still about twice as fast. And then when we have both of them enabled, it's a tiny bit slower, but that's because these are all really, really simple stored procedures. The bigger and more complex the stored procedure is, the more you see this number of doing both of those together, it starts to pull away and get faster and faster and faster than option 2. The other thing that I want to point out here as well, excuse me, is that this query alone is really worth holding on to and just checking to see how much time it takes your different kinds of queries to run so that you can figure out whether you need to change any. Maybe, which one should I take a look at to fix? So let me clean up here. All right. Was that a new lesson for anyone? Did everybody know that one? Okay, so I hate to say this, but I don't have time for all 10. So let me skip ahead, or you know what I'm going to do? I'm going to skip the slides and I'm just going to show you in the demos things like coding standards and do all the thing code, which is called kitchen sink kind of stored procedures, where you see a where clause like this. So let me just jump over and show you this kind of stuff. Okay. So coding standards are interesting. You know, I always like to joke that you don't need to use my coding standards like that I've written about in SQL in a nutshell, even though they're the right coding standards. But you and everyone on the team needs to use somebody's coding standards. And the reason for that is we're told that SQL Server will reuse execution plans in the query, in the plan cache of the SQL Server buffer pool. However, there's some caveats to that, okay? So here, somebody on the team likes to use camel case, okay? So we'll go ahead and execute this query. And let's just check to make sure it's in the cache. So here I'm going to execute a variation of my query. I see that it's 40 kilobytes in size. It has a use count of 1. Now that's Dan. Let's say this is Dan here. He likes to get as much as he can on one line. I, on the other hand, prefer to start each new keyword on a new line. Okay. So when I execute this one, okay, got my result set nice and fast. The data we do know is cached, but what about that execution plan? Well, SQL Server's smart, right? It's going to reuse execution plans wherever it sees like for like. But hey, wait a minute. How come I've got 2 separate plans in here, each consuming 40 kilobytes with a use count of 1? Or let's say in this case here, you're just not that particularly interested in precision. So sometimes you have an extra space in there. Sometimes you have or miss a capitalization. And SQL Server is smart, right? It's going to reuse that execution plan. So let's look at that. Oh, wait a minute. We've got 1, 2, 3 execution plans. What's going on here? You know, and then some other maniac out there, absolutely insane person, doesn't capitalize any of their keywords at all, which is really just evil. And so let's see, you know, SQL Server, you're telling me you're smart, you know how to solve these things and reuse the code, but now we've got 4 loaded in the cache. What is going on? Now, if we come back and execute one of these that is identical to what's already been in the cache, we will see that the plan use count does go up on that specific one, but we've experienced now something called cache bloat. And that's because we simply don't have standards where everybody codes in the same way, because what SQL Server puts in the plan cache is a hash of the binary values here. And what we all know is that a binary lowercase s is not the same as a binary uppercase s. And so SQL Server won't find it in the plan cache. And so you'll see all kinds of issues with plan cache bloat, because I wrote my query with uppercase keywords and 2 other developers on the team either use lowercase or mixed case, right? So it wastes a ton of space. Now, the last one that I'm going to show you is the kitchen sink stored procedure. So here's an example. We've got this stored procedure where we can pass in the last name, the store ID, the customer ID, and the minimum spend. And we will look up all of this information for the query. And we have to take into account that maybe this value is null up here, right? So if it's null, that means we've got to have all of these OR conditions, and it makes for a very large query where the code has to take into account all possibilities, okay? So I'm not sure, did I already run this? Let's see. Okay, it's already in there. Now, what you want to do instead of coding in the where clause for every possibility, you want to use something called dynamic SQL. And with dynamic SQL, what we do is we create a variable, and call it what you want, SQL or SQL command or what have you. You put the part of the query that doesn't change at all, this part here, you put that as the first element that you store in the SQL variable. And I also here have a always true where clause, right? Where 1 equals 1, that's always true. So that means it's basically going to ignore it, SQL Server will. Then, based on whether any of the values that are passed in are not null, I append an and to the where clause. And P last name equals the value for last name, okay? And then once I put all of that together, the last thing I do is I execute that SQL statement dynamically. So now let's hop over. I'll show you in Plan Explorer here. So here we have the execution of that command where we have the typical kitchen sink, and then we have the dynamic SQL. And what you'll see when we look at the rule or the result set, first of all, of course, is telling us we have some big differences between the estimated and actual rows. So there's some red flags going off. And notice we don't have that happening with the kitchen sink. I'm sorry, with the dynamic SQL, until we finally get to a variation of the query that uses an index that's out of date, right? Also notice how much less they are in terms of the processing required to answer these queries. So they're much simpler executions based on the parameters passed into it. So rather than having a giant stored procedure or piece of SQL code to handle every possibility, instead of doing that, what you do is you create a stored procedure that only adds on to the query those where clauses that are called for in the query. Otherwise, why even bother to try and cache data, sort on indexes that you're not using at all, okay? All right, so we're out of time. Don't have time for these last little bits here. So let me just jump ahead, actually. Couple quick things in summary. Use that test harness. You can clone production so you get identical execution plans, not performance, but the execution plans will be identical. And then you can look for the red flags. If you see red flags, then tune it. And I taught you a little bit about the major red flags, about workload differences, about how functions disable indexes, the good cursor, which is local fast forward, And to use set no count on, touch about implicit converts, coding standards, dynamic SQL. And the last thing we didn't have time for was table variables versus temp tables, and also versus CTEs. So with that, it's time for Q&A, but Dan, how are we doing for time?
This is Josh. I'm stepping in for Dan. We've still got about a half hour if you want it.
Okay, cool. Yeah, I will have to put a time cap on that. Yeah, so do you want to hit me up with a question or two?
See, one of the questions was, I'm not too sure what they meant by it, but they get duplicate rows with a cursor unless it's static.
No, will you get duplicate rows with a cursor unless it is static? The rows you get are dependent upon the time, the records that are present in the tables that you're querying at the time of the query. So what the static option does is once you have returned a result set, it kind of fixes that result set until your cursor is entirely completed, as opposed to checking during the fetch operation. If something new has come in, it's possible that it might show up at that point. So, but I'm going to be honest, I could be speaking out of the side of my head. I haven't looked at that static option in a long time. So let's go back and read the docs and see what it says to make sure. I don't ever use that option. Good question.
I know one of the other questions that got tabled earlier was the group by versus distinct.
Yeah, now that's interesting. Group by and distinct are really very dissimilar features. So distinct is used to kind of rule out non-unique values in a given table or in a result set of a query, I should say. However, group by, what it does is group by kind of does a roll up. So if you had multiple categories, let's say we're doing a query on the number of the amount of sales we've made by counties in a state. If you did distinct, you might get thousands and thousands of records because there's thousands and thousands of distinct sales in that table. If you did it by group by, and there's 48 counties in the state, you would get 48 records back, each one grouped by the county and giving you a total value of the sales for that given county. So with group bys, there's a second part that a lot of people forget about, which is group bys are almost always paired with aggregations like average or the sum or the count or the min or max of a particular value, a particular column. So whereas distinct does not need to be associated with an aggregation. So distinct just says for these columns on a table, make sure that that array of values are unique. Don't show me if the same thing shows up more than once. Whereas group by would be to say, okay, here's a column or two or three columns, and they are the ones I want you to group by, county in this case, based on the aggregate value. So show me each of the distinct counties, and for each distinct county, give me a total, if the column said sum, for the sales. I may not have explained that well.
Yes, Kevin, I asked the question. So I work on a lot of legacy code where I encountered where I would expect a distinct. So for instance, if you, your sales example, if you were looking for just the counties that had sales, I would do select distinct counties. But what I found was a group by without an aggregate. And I thought that was going to be a performance bottleneck, and I compared with the clean buffers, what, and I tend to get better performance with a group by without an aggregate to pull out distinct combinations of rows.
It is possible to use group by without an aggregate. Again, you can see my book over my shoulder here. That's kind of, it's a non-standard way to do things. And so it's an unusual practice, and I never do it. I never advocate to do it that way. So, that could be a problem. It could give you inconsistent results. It could also, that's the kind of thing that could change heavily if you ever have to move between two different database platforms where it works on one, it might not work on the other, and even different versions of the same database platform. And so you'd have to put on some kind of trace flag or option or hint or something like that to enable it to continue to work in the new version of the database that you're working with. It's a good question though, Carol. Another thought that comes to mind too is I just completed a couple presentations. One was how to do a database design review, and the other was how to do a Transact-SQL code review. And I initially wrote all of the scripts that I use and demonstrate in those presentations when the company I work for was doing a lot of purchasing of packaged products. And so I wanted to know which of the different vendors selling a solution that we were examining, which ones had better code quality, better database design quality. So you can see those on SentryOne.com/webinars. And it will do things like look for issues with group by and no aggregates, and things like that. So it will help identify a lot of different problems there.
Thank you.
All right. I'm taking a note though, because that is a really good question. I should have that answer.
Yeah, can I elaborate on the static forward cursor?
I'm sorry?
Can I ask the question about the static cursor again?
You can restate the question. I'm not sure if I'll be able to answer the question for you though. Yeah, go ahead.
Yeah, so I noticed, I think it's basically sort of a payment recons kind of thing. And after processing the batch, the person sort of checking would always pick up one payment that was booked twice kind of thing. And I got rid of that by making the cursor static. And I could never understand why my cursor would visit the same row twice, but making it static got rid of that, and I left it at that. But yeah, it's not as if there was sort of the select statement would get an extra row while the cursor was running. It basically visited the same row twice, and it baffled me. But making the cursor static got rid of that.
Yes, that is correct. If you define a cursor as static, what it does is actually kind of creates a temp table. So it goes out and pulls the entire result set that you've asked for, creates that temp table in WorkDB. I'm sorry, that temp table in TempDB, and all requests are answered from that temporary table. If you don't declare static, then what SQL Server does is it is executing there's a while loop in the cursor, and it's possible that it might find a new record that has been inserted. Let's say it's a busy production system with a lot of inserts and updates and stuff happening all the time. And so it actually may find an additional record or three or however many might happen as it is processing from start to finish. So it's the kind of thing that you would use it to safeguard the result set of that particular query while it is processing. Whereas in some cases, you don't necessarily need to do that. So again, it's the kind of thing that I don't use often, but and it's been decades actually since I've used it, but it could be very important for certain kinds of applications. What other kinds of questions do we have?
I'm not seeing a whole lot right now. If you want to go ahead and plug where people can find you and anything else about SentryOne you'd like to.
Yeah, someone asked at one point about the monitoring products, if they're all going to merge into one. And no, not across the full portfolio. So we have DPM, DPA, and SQL Sentry. So among the Sentry products, we did have like BI Sentry for analysis services and database Sentry in case you were running Amazon RDS or Azure SQL database. Now what we're doing is we have basically a cloud SQL Sentry license, and we have a full SQL Server SQL Sentry license. So we're combining all of the SQL Sentry or SentryOne monitoring products into one license, but there you could still buy, say, DPA for 20 of your servers and SQL Sentry for 10 of them, because those are really, really important mission critical servers, whereas the DPA is not as in depth as SQL Sentry is. And so it would better suit your bottom line to have a mix rather than all the same thing. So, and if you're a current customer, first of all, I thank you, and my children thank you. There won't be any change anytime soon. That's a massive change. And on top of that, if you've ever used our support and it's world-class, that also is not going to change. Also, I do want to also throw out, I hope you could see the value of Plan Explorer, so that if you ever do query tuning, that you really should have Plan Explorer. And it doesn't even ask for an email address. So it's not like you're going to get spammed or anything like that. So someone also did mention that they did not see if the session was recorded or not. So the good news is, again, you can go to SentryOne.com. It's not webinar videos. I don't know how that got in there. It's webinars. That's a synonym for webinar library. So if you want to see a slightly older version of this, but it has all the same content, then go to SentryOne.com/webinar library, and you can see all of the query tuning videos. There's probably 6 or 8 of them there, of which this presentation is one.
Kevin, that's fantastic. Thank you so much.
Yeah, thank you, Josh. I appreciate you helping out.
Yeah. I don't know if anybody else has any more questions, but I think we are recording it too. We're going to put it on our Kansas City SQL Server user group. But yeah, definitely go to Kevin's and check out all that they have to offer there. And thank you everybody for coming and joining.
Before we go, Josh, and before everyone else goes, don't sign out yet. I was going to give away an ebook version of SQL in a nutshell. So do you want to roll a die, or
let's see how many we've got? 19 people in here.
Right.
All right, let me see if I can.
I know if you go to Google and just type in like 1 space D20 and hit enter, it'll roll like an old D&D 20-sided die for you and give you a number.
All right, looks like we are on number 8. So let me see who our lucky winner is. Kathy O'Grady.
Are you with us, Kathy?
I am, yeah. Kahal is the name.
Sorry. Cathal.
Oh, no, there is a person named Cathal O'Grady.
Cathal O'Grady, yeah.
Oh, there's also a Carl O'Grady. Okay.
Is that could be the Carl, is it?
I will, I'm not sure what the best way of putting you two in touch to.
Just, Carl, just see my email address here. Just send me an email that says, I won SQL in a nutshell ebook at the Kansas City SQL Server User Group, and I will get that in process for you.
And Luke, that'll go off tonight.
Sorry? All right, and with that, everyone, thank you so much for your time. You know, I know you've got a lot to do, and you got families to support, so I appreciate you spent the time with me.
Thank you for being available. This has been fantastic.
Great. Thank you, everyone. Take care.
Bye.
Bye.